you so much, Oliver and Katrine, for inviting me to this and organizing everything. I really appreciate it. Thank you for everyone who's attending. I hope this will be interesting to you. I'm going to talk today about combining qualitative and computational methods, as Oliver suggested. And in particular, I'm going to talk about two forthcoming papers that do this in two slightly different ways. And I understand that I'm the guinea pig in this seminar series, so I don't really know what to expect either. So I'm going to try to keep this conversational. And to me, that means that you can feel free to post a question in the chat or raise your hand to ask a question at any point in time. And that way we can kind of keep a conversation going about these two papers and about the methodological issues at hand. Obviously, if we get through the entire presentation before the end of the session, there will be an extended amount of time for more questions and answers afterwards. If you have questions that do not directly pertain to what I'm presenting, I'm happy to address those as well. So one of the mainstays in my research has been this idea of combining qualitative and computational methods in various ways. And I've increasingly come to the belief that this is something that more or less all computational scholars actually do. Sometimes it's not really shown in manuscripts, but I do think that having a qualitative understanding of a phenomenon often is necessary in order for us to interpret and set up computational analyses of various kinds. And in my 2020 JS paper on this, I posited that there is this interdependent relationship between what I call human and machine pattern recognition, meaning that we're constantly iterating between using computational tools, setting them up based on our understanding of a phenomenon, and then interpreting them based on our understanding of the phenomenon. And our understanding of the phenomenon as human analysts, it often comes from talking to people, reading about a phenomenon, and trying to gain some type of insight, which I would call qualitative, into how a particular phenomenon works. And through iterating across these two aspects, we can identify discrepancies with theories that already exist and use those discrepancies to update and reframe the theory to create a new theory. And that's how I see the interplay between computational and qualitative methods continuously revolving around testing, formulating and testing working hypotheses, comparing them to theory that already exists, and then updating that theory to create different emergent theories of various kinds. So for me, the interplay between computational and qualitative is intrinsic to using computational methods in the first place. And I think some of you commented in the chat that you read this paper. If you haven't, you can review it later. It spells out in a structured way my approach to dealing with both computational and qualitative methods together. Now, I don't know if I would call this a particular method. I think I would rather call it an approach or a set of inclinations towards using data in particular ways. And it's hard for me to articulate one way of doing this. So for today, I'm going to tell the story of these two papers, which are forthcoming, and to show you some of the different ways in which this can be done and some of the learnings that I've had along the way of doing so. So I'm going to start with a paper that is mainly a qualitative paper, but that also has a computational component. And later on, we're going to talk about a paper that has mainly a computational component and then a more supplementary qualitative component. And this paper is forthcoming in MIS Quarterly. It's called Discursive Modulation in Open Source Software, How Communities Shape Novelty and Complexity. And it's with my co-authors, Nick Berenti, James Howison, and Calvi Lyytinen. And Callie was my advisor, and it was also Nick Berente's advisor. And we have obviously done a lot of work together. And this is why you may see, as someone said in the chat, that there are similarities between this work and the publications that Nick Berente and others have in ISR and MISQ with regards to computational theory construction. This is very much research done in the same vein, coming from the same tradition at Case Western Reserve University, where Nick and I did our PhDs. So in this paper, we examined 2 different open source projects, and we identify how they engage in what we call discursive modulation practices to shape novelty and complexity. So discursive modulation practices here are ways in which people intervene in the development process through the conversations that they have on forums, in conferences, on GitHub, etc., etc. And that's a way for leaders of a project to shape the way the work is being done in the absence of hierarchical structures. And based on our research, we formulate a theory that explains how modulation results in different approaches in different communities to shape software novelty and to shape software complexity. And we do this mainly through qualitative analysis, and then we analyze the software artifacts that are created using code-based analysis. And very briefly, I'm not going to go into detail into the substantive matters of the paper because we're going to be focused on methodological issues today. But essentially, what I do is that I posit that there are 2 main processes of modulation. Modulation being a concept borrowed from audio synthesis and signal processing. And those are filtering and mixing. So you can filter out certain discursive positions, opinions, approaches that are seen as undesirable. And you can then mix together different desirable positions to create some type of coherent position with regards to how a software artifact is going to be created. That's how discourse is being modulated. And discourse, in turn, is implicated into a mutual shaping process together with the artifact. And here we focus on novelty and complexity, and we show how increased novelty creates new interdependencies, which increases complexity, and increased complexity then constrains new feature development, which impacts novelty. And obviously in the paper, we go in much greater depth into this, showing how there are different approaches to this mutual shaping process between discourse and an artifact, but this is the essential outline of our theory. Now, let's talk about how we did this methodologically and what lessons we learned along the way. So for this paper, we used a wide range of data. We used interviews that we conducted ourselves, both over Skype at that time. I guess it would have been Zoom now, as well as at various industry conferences that I attended. We found podcasts where people talked about the projects. We looked at recordings and attended industry conference presentations and workshops. We looked at blogs within these particular communities, mailing list discussions, and issues and pull requests on GitHub. And obviously, we also downloaded the actual databases, code bases of the projects that we studied so we can conduct code-based analysis on them. And an important insight here is that not all qualitative data is the same, and not all digital trace data is the same either. And what we found was that some types of qualitative data provided more exposition. Interviews probably being at the extreme end of this, meaning that interviews were very helpful to get an overall understanding of a project or a particular phenomena. It helped us get a tacit construct such as culture or a particular zeitgeist in a particular project. Other types of qualitative data provided much more detail, meaning that they provided us a view into the detailed practices that people performed as they worked through particular technical problems in open source software development. And the most detailed form of data were the issues and pull requests on GitHub, which deal with specific software patches and specific bugs. And then somewhere in between, you had mailing list discussions and blogs dealing with particular issues, et cetera, et cetera. And the lesson that we took from this was that it was useful to have all of these different types of data available, because they provided different types of things for our analysis. We started the process having mostly data that provided a lot of exposition, so interviews and podcasts, etc. And in the review process, the reviewers said that, well, this seems like to be a lot of very high level statements with regards to what's going on, but we want to see these things in practice. We want to see how these things are actually happening on the ground. And that led us to delve much deeper into mailing list discussions and issues and pull requests on GitHub, which provided that greater level of detail. So I don't think that every single paper needs to include all of these different types of data, but if it's possible in whatever project you're working on to include data that provides both more exposition as well as more detail, it's very useful to be able to see the bigger picture through data that provides a lot of exposition, as well as details of what people actually are doing day to day, through having data that gives you access to greater amounts of detail. So the qualitative analysis that we conducted was a form of abductive analysis. We used both grounded theory as well as drawing on the literature, and we iterated constantly between the literature and the data to show how a particular set of core doctrines and design principles in each project were enacted in practice. So in many ways, a fairly standard contemporary approach to qualitative research. At the same time, we used various computational techniques to capture novelty and complexity. And we found that this was, on the one hand, it was a process that was tightly interlinked with the qualitative data analysis, meaning that we constantly had to iterate between qualitative analysis and computational techniques to understand how particular ways of thinking and behaving within the projects were related to how the code-based structures were shaped over time. On the other hand, we also found that the computational techniques that we needed to use focused a lot on concept operationalization. So when you want to examine things such as novelty and complexity in software, you have to think very carefully about exactly what aspects of novelty and complexity is it that we're capturing. So throughout the process with this paper, we wound up attempting to try a large different amounts of different measures of complexity and novelty. So the ones that are in the final papers are not the first measures that we tried. And what happens over time is similar to what a lot of us experience when we use qualitative methods, is that you try a particular framing and that framing turns out to be awkward with the data, which forces you to reframe the way you see the data. And a similar process is involved with trying to measure concepts using computational techniques. And I've called this computational crafting, meaning that you need to find a way to measure, for example, complexity that truly matches how the concept is defined and how complexity in this particular case is discussed in the qualitative data. And what we wound up using it, well, let's put it this way. We started by, for example, measuring the folder structures of the different code bases, but we found that those measures were too ambiguous. And at the end of the day, we wound up measuring a concept called cyclomatic complexity, which measures the number of pathways through the code that a particular execution of the code can take, and thus shows sort of how varied and interdependent the code is in itself. And that proved to be an effective way of measuring the complexity of the code base. Now, that type of complexity obviously has drawbacks to it. It is an objective measure of complexity, so it's based on the code. And so it doesn't capture subjective experiences of complexity, meaning how difficult the code may be to work with from the perspective of the users and the developers. But that is the case with any type of concept operationalization. It will probably be good at doing certain types of things and not so good at doing other things. So you have to pick your poison, so to speak. All right, so I think we have a question here in the chat.
Yes, exactly. Thank you very much for posting that. I think it boils down to, the poster said that approaches of this combination of qualitative and computational methods were already in your dissertation, if they're correct. And how would you say has your method, or how would you say has your approach to this combination changed since your dissertation? And yeah.
Well, thank you, TC and Oliver. So yes, I think TC, you have. I think you told me at another point in time that you've looked at my dissertation, and it's obviously publicly available. For example, in my dissertation, the JAS paper that was on the reading list, and from which I cropped the figure that I showed at the beginning of this presentation, that was probably 3 to 4 pages in my dissertation, and the sort of the seeds of that paper was already in the dissertation. It obviously changed massively over time. These 2 papers were also part of my dissertation, which speaks to the long process of getting papers published sometimes. The first paper in my presentation, in my dissertation, was published 1 year after I graduated, so in 2016. But these 2 other papers took much longer time to get published. And how has my approach to mixing qualitative and computational methods changed since then? Well, I think if you look at my 2016 paper in ISR, which is also about open source software, I think what you're seeing is a much more complex structure in terms of iterating between different analysis. And I think that this was common in sort of the early days, now almost 10 years ago, of computational theory construction research. There is a great paper by Vast and Hani Safadi and others about the Gulf of Mexico oil spill. That's very similar to my 2016 paper in terms of having a fairly complex methodological structure. I think what I've seen in my own research is that the way I like to structure these manuscripts have become much simpler, which I think it makes it easier for reviewers to understand the manuscript. So if I go back, I think that I tend to now choose 1 out of 2 structures, and that will be to either focus on the qualitative component and usually put that first in the manuscript, and then have more of a supplementary computational component later on in the manuscript, or, as we'll see in the second paper of today, to have a more dominant computational component and then have a smaller qualitative component towards the end that supports the computational research. This makes it easier to put together a review team that sees things in the same way, through positioning one of these perspectives as the dominant perspective and having the other perspective be more of a supplementary perspective. If you have too many different types of analyses, maybe even different multiple computational analyses, you often make it difficult for yourself to gather a review team that can understand all of those things. And that can make your process difficulty. So Matthias, he asks, since you use podcast data, how did you analyze this data? Did you transcribe it similarly? And how did the analysis differ at all between interviews you conducted and podcasts you listened to? So this is an interesting question, because I think that this has evolved over time due to technological development. A lot of the interviews in my dissertation were transcribed by a professional transcriptionist, because we had the resources to do that. These days, when I conduct qualitative interviews, I no longer use a professional transcriptionist, because there are AI transcription services that are, I would say, 95% as good as a professional transcriptionist. So I think Zoom has a built-in transcription function. I've used a service called otter.ai that can transcribe any audio file that you upload to it. So that the transcription process has evolved over time due to the availability of AI transcription tools. So that's something that I recommend to all of you to look into. The AI transcription tools, they suffer from the same drawbacks that human transcriptionists do, that are not familiar with a particular context, meaning that they transcribe common English words extremely well, especially if the people you're interviewing speak English without an accent, etc. But they do less well with special terms of various kinds that may be context specific. I will say this goes for English. I don't know what the case is with these tools in other languages, such as German. Oliver and Ann-Cathrine, are there good AI transcription services for German language texts?
Yes, there are. And actually, you can use them quite easily. So I did it as well. I used interview data and transcribed it with AI-based tools. I would have to look up the name of the AI-based tools, and it has been some time since then. But it is really, really good. I mean, the quality has improved throughout the years. So I can only recommend it to do it this way. Of course, you need to, look through it manually, but there is not so much to correct.
Very interesting. So it's available at least in German and possibly in other languages as well. And this is something that can save you a lot of time and resources, because I'd rather spend time reading the interviews and thinking about them as opposed to transcribing them myself, which could take a lot of time for people.
May I perhaps add like a detail to my question? It's not so much about like using AI tool for transcribing as it is about, did you transcribe the podcasts you listen to? Because I'm in the current situation, I use interview data and I use podcast data. And I asked myself whether the analysis of podcast data differs from interview data to some extent. And did you also transcribe the podcast data?
Well, so a lot of podcasts, at least at that time, were transcribed by the people who were doing them. So I sometimes had transcriptions that were provided by a particular podcast website without me having to do any transcription. Then for some other podcasts, I did not transcribe them, but I use Atlas TI, which allows me to analyze the audio files directly. When it comes to the way of analyzing podcasts, for example, I don't think that it differs from interviews to any significant extent. And I think that's because a lot of podcasts, at least in this space that I've been working in, are essentially interviews. It's just not me conducting the interviews, but it's people being interviewed by a podcast host. They have a conversation about a particular topics. I don't think that the way of analyzing them really differs in any particular way, right? What can be interesting about the podcast is that it's more what I would call shop talk. So they talk the way that they would talk to a peer in their community, as opposed to trying to explain it to an outsider. So sometimes that provides a little bit less exposition and a little bit more what I would call detail, closer to the work that they're actually doing. So I think it provides a good complement to interview data, but I don't think that the way of analyzing it actually is particularly different. So, and I don't know about a specific paper on podcast data analysis. All right, so we have some recommendations in the chat about German AI transcription software. Hopefully there are other software in other languages too, but I'm not aware of that. Okay. So we talked about the method, how we iterated between qualitative analysis and computational techniques, and also how the computational techniques had to be refined over time to find the right concept operationalization. And I think that this is important to think about, because with digital trace data today, unlike survey data, the concepts are not directly measured in the data. Rather, you have to find a way of expressing a particular concept using some computation on the trace data that you have available, and this is often quite difficult. So in our particular case, we've discussed complexity. We used a measure that is used in the software development and engineering industries themselves to measure complexity. So it's a measure that largely makes sense to the practitioners within this area, and that's usually a good way to go. Because then you'll have a measure that matches up with the way how people use that concept or that word in the particular context that you're examining. Now, it's not always the case that you can do this. And what I see in a lot of papers, and what we struggled with early on in this process, was that we had very thin measures that could mean many, many different things. And here the qualitative analysis is very helpful to provide a little bit more thickness and richness to the computationally measured concept that suggests a particular interpretation out of the many possible interpretations that are possible with regards to a very thinly measured concept. All right, so talking about framing, we reframed this paper multiple times. First, we use a framing from a paper by Anne-Laure Fayard and Natalia Levina at NYU, which discussed the idea of epistemic stances, meaning how do you view knowledge and its application in a particular design and innovation context. And that did not work out for us. And eventually we moved to this idea of discursive modulation. And what was helpful about this framing was that it helped us move from a concept that was more cognitive towards a concept that was more practice oriented. And that is helpful because it was easier for us to observe a more practice oriented set of concepts in the data, as opposed to observe more cognitive aspects of what people were doing. With many kinds of data that we're working with, I find that it's often easier to have a slight bias towards observing behaviors and the things that people are doing, practices, etc. And sometimes a little bit harder to really get into the heads of people to understand the way they are thinking about different things. We also reframed the paper from talking about generativity and technical debt to novelty and complexity. And I think that this also represented a framing from broader concepts towards more specific concepts that were easier to measure. And all of this entailed an iterative revision of how we operationalize these concepts in a computational manner. So it wasn't just rewriting the front end and the back end of the paper, it was a continuous reframing of the way we interpret the qualitative findings and the way that we computationally measured the constructs that we dealt with. So not all papers go through as much reframing as this paper did. And we'll see in the second paper I will talk about today, where the process was very much more straightforward. But here we saw a very extensive set of reframings, and it's always risky to reframe a paper, but it can definitely help different parts of a manuscript align better with each other. And I remember during my PhD, it was probably in 2014. So 10 years ago, I drove to Carnegie Mellon together with Callie to present this paper, a very, very different version of the paper at that time. And I asked Callie, like, I think we have a good, framing on this. Do you think it's going to change a lot from now on? And he said, maybe it will change a lot. And it did change quite a lot from that point in time. And I know it feels like you're in the middle of your PhDs, you've already done a ton of work on your papers, but there may be many reframings that you will have to do in the future of your papers. And while it's tiresome, it generally leads to a better paper and helps to align the different parts of a manuscript together. And I found, maybe other people can do this better than me, but I found that I can't really evaluate a framing before I try it in the manuscript. So I think reframe the papers you have if you get comments that suggest that, and see whether you arrive at a better framing. Hopefully over time, you frame the paper better and better. So Anuragini asked, did reviewers consider such work lend itself to mixed method approach? I'm not entirely sure I understand the question. What do you want to ask the question verbally, Anuragini?
Yeah, sure. I mean, normally when we use different methods which are qualitative or quantitative, or even for that matter, qualitative and computational, one could think of actually sequentially positioning them or parallelly positioning them, which is what you seem to have done, because it's discursive. That's the term you have coined. But since I have experience in mixed methods, I was wondering if this would also fit into, would you also frame the study in the research design as a mixed method research design, which is parallel frame,
So I think on the one hand, this is mixed methods research. On the other hand, I think that mixed methods research, to me, it's a slightly older paradigm that signals that you're mixing different things which are quite different from each other. So if you go back 10, 20 years, you'll have mixed methods research, which combines, for example, interviews analyzed using grounded theory on the one hand, and then survey data analyzed using regression or structural equation modeling on the other hand. And those different types of methods tend to rely on very different assumptions, epistemological assumptions about how the world works. And I think that, and sometimes, you'd call that work more positivist, and you'd call the work more, the qualitative work more interpretative. But I think what's happening today is that computational methods are becoming so sophisticated and so diverse and varied that I think that they are starting to overlap more and more in terms of their epistemological assumptions with qualitative research. So in my mind, I don't think that there is a great difference between qualitative research and computational research in terms of the epistemological assumptions behind it. For example, using computational methods of various kinds, such as text mining, you can increasingly analyze interview data, and you can the computer can assist you in interpreting the data in various ways. So I would say that computational methods can be interpretative as well. And increasingly, whatever concept you're interested in, you can often define some way of measuring it computationally from digital trace data. Now, the drawback of those interpretations tend to be that they are rather thin and can have multiple interpretations. And this is where qualitative data comes in and helps you to establish a particular interpretation that seems reasonable, thus helping you to interpret what a particular computationally crafted concept means, or what a particular correlation between multiple concepts actually mean, right? So Jan Pei had a question here saying, can we assume that computational methods is rooted in a positivist paradigm? And is it possible to use computational methods to do interpretivism study? And I think for me, this is the sort of more old school mixed methods thinking. I would not say that that computational methods today are necessarily positivists. I think that they can be used for interpretation as well. And I also think that because there are such a vast range of different computational methods today, you have to kind of use a qualitative mindset when you use computational methods, and think very clearly about what is it that I want to measure? What is it that this data suggests to be? Because computational methods doesn't really restrict you at all in terms of what you can measure. And that's an opportunity, because you can craft exactly the concepts that you're interested in. And it's a challenge because you may be creating a particular measurement of a concept that reviewers have never seen before, right? So for me, qualitative and computational methods, they go hand in hand. And as computational methods become more sophisticated, qualitative and computational methods become more and more similar. And I remember a conversation I had with Brian Pentland about a year ago, and we were talking about computational methods and how to approach it for theory construction. And Brian Pentland, he said, well, I always thought of myself as a qualitative scholar. And obviously he's done qualitative research, but most of his research is what I would call computational method. But he has always approached it with a qualitative mindset. And I think increasingly that is something that's necessary, given how many different ways there are of using computational methods today. Okay. So I think we've already talked about the theorizing process. In the manuscript of this paper, it looks very straightforward. There's a big qualitative section, and then that's followed by a smaller computational section. But in reality, it was a very iterative process. And at various points in time, we had the computational section up front. We had it in the middle of the manuscript. We had it at the end of the manuscript, etc. So we iterated between the different methods quite frequently in this paper. And usually that's what we sometimes refer to as the context of discovery. As you're discovering the patterns in the data and how they hang together, you're working on all the different pieces all at the same time, trying to figure out the puzzle of how they all fit together. But then when you enter what's referred to as the context of justification, when you try to explain to the research community what it is that you found, it's important that you have a logical structure and that you depart from the messiness of the research process. And that's why you'll see in this manuscript how it has this very clear structure, qualitative first, and then a smaller computational section at the end. So the research process is often much more iterative than it looks in the manuscript. The review process was really long. It was 2 rounds at ISR, then it was rejected at ISR, then we did 3 rounds at MIS Quarterly, and it was a fairly risky review process at the beginning, but eventually the paper was accepted, and we did major reframing at both journals. And the lesson that I draw from this is that even if your paper is rejected, even if it receives harsh criticism, it doesn't necessarily predict doom and gloom for your manuscript. Most of my papers that have been published have been deemed by a reviewer at one point in time to be highly risky revision, or it has been rejected at one journal and then accepted at another. And so these are things that happen frequently. So when you get rejected, it's just one step in the journey. So keep your spirits high and continue reworking your paper even if they get rejected. Rejection is just a part of the everyday work that we do, and even the most experienced and prominent researchers that I know get rejected frequently. Okay, so that was the first paper. So before we move on to the paper that's focused more on the computational component, do we have any additional questions with regards to this more qualitative heavy approach?
Yeah, Aaron, I have another question. So it's to do with level of analysis. Did anybody question that when you mixed podcast interviews and the GitHub data and all of that? So what was the level of analysis? Was it at the trace data level, you know, text, or was it at, you know, I don't know, in your case, project, maybe project levels? I'm not sure.
Yeah, so this is a great question, and now that you say it, I should have mentioned it in my slides, because this was something that we grappled with throughout the process on multiple levels. So we grappled with it with regards to the qualitative data, in the sense. Okay, I have to. Sorry, my computer is saying that it's going to restart. We don't want that. Okay, well, hopefully it doesn't restart. Sorry about that.
No problem.
So we based a lot of the initial versions on interview data. And the comments that we got were that this gives sort of the manuscript a too expository field. In the sense that we made these high-level statements about culture, about the way in which things were done in each of the projects, and the reviewers felt that this was too much tell and not enough show, and this encouraged us to gather more mailing list data and issue pull request and bug report data from GitHub to really get into the practices on the ground of what people were doing and do more showing of the data as opposed to just telling with regards to the data. So we implemented a fairly large number of vignettes in the paper that showed particular examples of how the processes we were suggesting theoretically, how they unfolded over time. So that was one important aspect of the unit of analysis, kind of move from these like high-level expository statement that we got from interviews towards more detailed practice level examinations of what people were doing on mailing lists and in the bug tracker on GitHub, etc., where we could observe the actual work happening. So that was the one way in which we worked with unit of analysis to figure that out with the qualitative data. The other aspect that we did was that we were trying to explain how you could shape something called novelty and complexity. And what was really difficult about that was that we started out by thinking of novelty as complexity as something that, which we at that point called system level features, right? Meaning that the complexity and the novelty is not necessarily a feature or an aspect of or a characteristic, I should say, of a single bug fix or a single new feature, but rather these are aspects of the entire project. You get a sense of how novel a project is, or how complex a piece of software is as a whole. And the reviewers felt that this was very difficult to understand. What do we mean by these system level features, etc.? So what we did was that we backed away from that way of thinking about what novelty and complexity were, and at the same time we created these much more tangible operationalizations of the concepts. And I think that what happened was that as our concept operationalizations became more tangible and became closer to both what seemed acceptable to the reviewers and the IS literature in general, as well as matching up with the way that people in these open source communities understood these concepts or these words, novelty and complexity, then I think that the reviewers felt more comfortable with those concepts rather than us sort of inventing this very high level sort of idea of system level features or system level characteristics. So trying to figure out what kind of level at which we were going to analyze things was a big struggle in this manuscript, and generally there was a trend towards making things more tangible and easily understandable over time, and making things less high level, less diffuse, less ambiguous over time throughout the review process. So that's what I would say about unit of analysis.
Yeah. But then there's this question of what does this theory, what are the boundaries of the theory at the end of it, whatever, the complete model or the findings of all of these iterations that you've mentioned. So if anyone else has to use it, any theory would have some applications or boundaries. So without knowing, where does it apply, isn't it difficult to then reuse the theory?
Absolutely, you need to specify the boundary conditions of your theory, and this was something that we discussed a lot with the reviewers across the review process overall, and essentially what we're doing is that we're conducting two comparative case studies where we're looking at two projects, and these were web development frameworks. They were both successful. They were both mid-size projects hosted on GitHub. So there is a particular empirical class of phenomena that we think that our theory may apply to. Also, the theoretical generalization that we do is analytical in nature. We're not trying to claim that this theory will be applicable to all projects that share those high-level characteristics, but it provides a set of archetypes that can be helpful for understanding how different open source projects actually function. And in this paper, we provide two such archetypes, but by no means are these the only possible archetypes.
Okay, great, thanks.
So, Jan-Pei, you asked, can you share more about how to do the concept operationalization? Do you have a more specific question, Jan-Pei? Well, I'll okay. So if you have a more specific question, Jan-Pei, you can write it down in the chat, and I'll get back to your question in a bit. Mahdi suggests I share this paper. This paper should be available at first look quite soon at MIS Quarterly. Are there other papers with similar combinations of qualitative and computational methods? Yes, there are. So I'm right now writing another methods paper where we exemplify 6 different papers that combine qualitative and computational methods in different ways. So there's definitely other research that combine things in a similar way, with slight variations emphasizing different types of things. So I can provide a list of those papers to Oliver and Ann-Katrin afterwards, and they can send it out or add it to the reading list. Let me take a quick note of that.
We're happy to provide the reading list on our website of SIGDITE. So there you already will find some readings up front there, and then you can also see those papers that Aron just mentioned. We will put them there.
All right. So, okay, so now it says, okay, now I'm sharing the screen again. All right, great. So the second paper that I want to talk about is also forthcoming, and it's a paper that's mainly computational in nature, but it also has a qualitative component. This is forthcoming in MIS Quarterly, and it's called the Entrainment of Task Allocation and Release Cycles in Open Source software development. And my co-authors are Aron Schechter, Nick Brente, Kalle Lyttönen, and Phil Hennel. So in this paper, we identify a process of entrainment. Entrainment is when two cyclical processes start to synchronize with each other spontaneously. And we identify such a process around open source software development release cycles to capture the patterns of self-organized task allocation among developers. So developers in open source are volunteers, and they self-organize which tasks that they take on. And we show how particular patterns in task allocation changes across the release cycle. And to do this, we conducted an abductive study. It was computationally intensive of 8 different open source projects. And we used relational event modeling, which is a computational techniques that combine graph analysis and sequence analysis. And we analyzed a large number of actions across a large number of software releases in these 8 different open source projects. And that helps us to identify a set of patterns with regards to how task allocation changed across the release cycle. And then we use qualitative analysis to understand the mechanisms which generate entrainment of task allocation and release cycle. So here we have more or less the opposite structure that we had in the prior paper. We're mainly using a computational modeling. And then as an adjunct to that computational modeling, we have a qualitative analysis that help us to zoom in and go more in depth to understand the mechanisms which generate the patterns that we observed using computational analysis, right? And what we find is that there are basically 3 overall stages in open source release cycles. First, you have a steady state that's largely characterized by individual work on popular issues. Then as a major release is starting to approach, developers move into what we refer to as a concentrated mobilization stage, where people start to focus on the particular issues that they are the most interested in. And then after a major release, they enter what's referred to as an extended cleanup phase, where a large number of developers engage in lots of different bugs to clean them up over time, so that the release becomes of higher and higher quality. So in this paper, we used digital trace data of development actions. So we scraped these things from GitHub, and then we used mainly interviews to provide a qualitative account of the generative mechanisms behind the patterns that we observed. And as you saw on the first slide presenting this paper, it's a fairly large research team. And I think what we see in at least some of these computational theory construction papers, or papers which combine qualitative and computational methods, is that they often need larger research teams with multiple competencies. So in this paper, for example, we had Phil Hennel, who did the digital trace data collection, so scraping GitHub. We had Aron Schechter, who did the computational analysis using relational event modeling. And I collected all the data, all the qualitative data, and analyzed the qualitative data. And then I did the conceptual framing and the theoretical development of the paper. So these types of multi-method, computationally intensive papers, they often benefit from larger teams. And this is can be a struggle for you as a PhD student, because as a PhD student, you are expected to do everything in your dissertation. And I think my advice to you is to focus on the things that you're really good at, and don't try to be good at everything. And then for your papers, see to what degree you can team up with other people who have complementary competencies. I think for me, this is becoming more and more important. And I think this is going to become more and more common, because even if someone is a computational analyst, they're not going to be skillful at every possible computational analysis. Some people might be experts in social network analysis, other people might be experts in data gathering or in text mining, etc., etc. So you may need to work with multiple people across your career, and maybe even in the same paper, in order to create a strong analysis. So we've discussed this previously, how we used the relational event modeling to show the evolution of task allocation over time, and how we use the qualitative analysis to theorize the generative mechanisms behind those patterns. And this is a helpful way of using the strengths of each method to complement the weakness of the other method. So lots of computational methods are able to consume very large amounts of data and identify patterns which hold across a very large data set. These things are often very difficult, if not impossible, to observe with just a human eye. And computational statistical methods are helpful for identifying these large-scale patterns which cover an entire data set. These patterns also tend to be what ethnographers call thin, meaning that they provide a very sort of set of narrowly defined concepts and how those concepts are correlated with each other, but they don't provide what ethnographers would call a rich or a thick description of a particular context that gives you a sense that you are situated in that context and understand the way that people think, feel, and behave in that context. And this is one of the strengths of qualitative methods that helps you to kind of really get inside of the heads of people, to get inside of the context of the environment that they work in, to understand it. And once you do that, it becomes so much easier to interpret your statistics, your computational analysis in a way that that makes sense. So I think it's really helpful to use qualitative analysis in this way to thicken up or enrichen a computational analysis. This paper had a much easier process of framing and reframing compared to the other paper. We started with a framing focused on developer attention. And at this point, in the first submission, the paper was only computational. It had no qualitative component to it. And what the reviewer said was that this is all well and good. This might be about developer attention, but you're fundamentally not observing attention, which is a cognitive construct. You're observing people's behavior and how people allocate the actions that they take across different problems in an open source project. So during the review process, we shifted towards a more behavioral concept. So we shifted from attention to focusing on task allocation, and we shifted towards this idea of entrainment to show how task allocation and release cycles entrain to each other. And what was helpful about both task allocation and entrainment, as opposed to focusing on cognition and attention, was that they were observable in the digital trace data. And I find that this is often the case. In the prior paper, we talked about data which is more expository, such as interviews, and data which is more detailed, such as digital trace data. And what tends to happen is that the trace data is often thin, it's detailed, and it tends to benefit from a focus on behavior as opposed to cognition or affect, which are often really hard to get at when you're looking at trace data. And if you're framing your trace data in terms of cognition or affect, at least the type of action data that we worked with here on GitHub, reviewers tend to say, like, well, this is a little bit awkward. You're not really observing cognition. You're not really observing affect. You are actually observing different types of behavior. I think if you were applying text mining to a set of long form text, you might see a different situation where the cognition or affect becomes more visible. But if you're looking at digital trace data from a platform such as an open source software development platform like GitHub, you're probably more likely to observe behavior in the data. So that was an important insight for us that made the review process easier across time. So Ann-Katrin, you have a question here. You say, how do you introduce the minor method in your paper? Is it supplementary to gain further insights? And how do you position a paper having a major and a minor method to avoid reviewer comments on neglecting richness in the minor method? Well, we've definitely throughout these review processes received all of these criticisms. I think a mistake that I made in my 2016 paper on open source software development in ISR was that I used lots of different analyses and with lots of different characteristics. And that made it very hard for the reviewers to place the manuscript in a genre. These two papers that I'm talking about today, they were always from the very start positioned as mainly a computational paper. That's the paper we're talking about right now, and mainly a qualitative paper. That's the paper that the first paper that we talked about today. The prior paper from today always had a computational component, but the paper we're talking about right now didn't have the qualitative component added until almost the last review round at MIS Quarterly. So I think what happens is that when you have a major focus, methodologically speaking, in your paper, you're more likely to get a review team and a set of senior and associate editors that are focused on that particular method, which means that most of the focus on the review process will go to that particular method. So not every part of a manuscript can be equally cool, equally interesting, of the same quality. And I think what happens is that you have to prioritize some parts of the manuscript over others. So that's kind of becomes one way of dealing with these types of concerns, saying like, well, these are the really strong parts of our manuscript. Obviously, you will have to strengthen all parts of the manuscript throughout a review process. But I think if the review team feels that there are some parts of the manuscript that are really, really strong, there is a little bit more slack, a little bit more forgiveness with other parts of the manuscript. Not every manuscript can be equally strong in every single department, right? But yes, in this paper here, towards the end of the review process, the reviewer said, well, you have all this trace data, but we don't really understand why people are doing these things. So could you add some qualitative data to better theorize the computationally identified patterns, which is what we did. All right. So the review process from this paper was, on the one hand, really long, and on the other hand, it was quite short because it was only submitted to MIS Quarterly and it went through the review process and it was accepted eventually. But it was also a really long process because I submitted it as a conference paper, and that conference paper looks completely different from the published MISQ paper. And in 2015, it received an AOM OCIS Best Conference Paper Award. And it took 5 more years before we submitted it to MIS Quarterly. And then it took 3 years at MIS Quarterly before it was accepted last year. So sometimes it just takes a long time for these manuscripts to get accepted. I don't think that every paper takes this long to get accepted. But I think that you should probably expect many of your paper to take somewhere between 5 to 8 years from initial conception until publication. And it can be much faster. I finished my dissertation in 2015, and in 2016, I published my first paper in ISR, but that's not the norm, at least not for me. Maybe some other people are really fast and can publish in the top journals just within a year or two, but I don't think it's super common. Now, during this review process, it was crucial to add co-authors, which had data scraping and computational analysis skills. we started with a smaller number of projects, so we collected more data throughout the review process. And also, we changed the computational analysis several times between 2015 and 2018 or 2019, when we started working with relational event modeling. So there were lots of different things that we tried across times, and it was crucial for me to put together a team that were really strong in all aspects of the manuscript. The review process was relatively straightforward. Obviously, we rewrote the manuscript many times. The structure of the manuscript changed completely. We started from scratch in at least the first 2 review rounds. What was not straightforward is the very large number of computational analyses that we conducted to provide more insights into the mechanisms which generated various patterns, to validate those patterns, to create simulations to show what the consequences of various mechanisms would be in the long run. So we did a very large number of different analyses related to the main relational event modeling analysis. And then in the last round, we added the qualitative data. And for this particular paper, we already had qualitative data at hand that was useful, which was great. But I also have other papers under review where we have gone back to the field to collect more qualitative data over time, which obviously is very time consuming, but increasingly this is something that happens. And I think when you're using digital trace data, you're using computationally scraped data of various kinds. I think that reviewers always assume that you can go back to the source and get more data. So what I find, both as a reviewer as well as an author myself, is that generally when you're working with digital trace data, you should expect people in the review process to ask you to rescrape the data, extend the data set, to add another data set, etc., etc. That's a continuous process throughout the review process, and very little of what I published that has a computational component has used exactly the same data set in the initial submission as in the final publication. There's almost always requests for more data or different types of data. So you have experience not only analyzing trace data in combination with a qualitative approach, but only analyzing the code product itself, such as code quality, combined with insights from interviews. I'm not sure I understand the question. Do you want to clarify?
Yeah, sure. So my question is rather about, so I noticed you use trace data in both of your studies, and through that you can observe the behavior, right, of the software engineers. And I'm just wondering, is this approach, basically combining computational approach with a qualitative approach, also works if you, in the computational part, only look at the product and how the product's code develops over time without really having this behavior trace data. What is your assessment on that? Would that work?
Well, it depends on what you mean. So the first paper that we discussed today, it looks at how the code bases of the 2 projects, how they evolve over time. And then we use mainly interview data, but also data from blogs and podcasts. It's all textual data to craft a story that helps to explain the patterns that we see, right? So you don't have to use trace data for computationally analyzing the work process per se. We didn't do that in the other paper.
Okay.
We only looked at how the artifact evolved over time, and then we use qualitative analysis of a diverse set of textual data to understand the discursive practices through which the artifact was shaped over time. Right. So you can do that. In this particular paper, we don't really say anything about the artifact, except that that it evolves through major and minor releases, and we focus on the work process So here we use digital trace data that captures the work that people do, submitting bug reports, submitting patches, et cetera, et cetera. So I think that there are multiple approaches that are possible. I think that what you should expect, though, is that a lot of times a reviewer will ask for complementary data, no matter which perspective you're coming from. So if you have a lot of interviews, they often want you to add some archival data. I have another paper under review, which is a fully qualitative paper. It doesn't have a computational component. And initially we used archival data, and then the reviewer said, like, well, maybe you should get some interview data as well. So I think if you can have a data set that has both expository as well as detail level components to it, I think that's going to set you up much better for navigating the review process, rather than focusing only one type of data, because that's going to make you a little bit more one-sided. Is that helpful with regards to your question?
Yeah, absolutely. Thank you. And maybe to clarify, this means in this first study, when you just look at the product, right, in the computational part, how it evolves over time, the practices and how the practices shape the product, those insights were coming out mainly from the interviews.
Yes, mainly from the interviews, but then through the latter part of the process, we identified episodes that helped us identify processes of discursive modulation, which is what we called in this paper. So not only what people were saying at an expository level in the interviews, but particular stories of particular bug reports, particular features that were being discussed, etc., so that we could show that the concepts that we largely got from the interviews also applied at the detailed level to the work practices that people were performing.
Okay, thank you so much. Thank you.
Right. In your opinion, can online product reviews be considered as digital trace data? Well, I guess it depends on what you define as digital trace data. I think a broad definition of digital trace data would be that any trace that's left in digital form based on a human action, whether that is writing or doing something else, counts as digital trace data. So from that perspective, yes, I think online product reviews can be considered digital trace data. You could also have a more narrow conception of what digital trace data is and say that it doesn't really cover people writing things on the internet or providing video content or audio content, but that the trace data are only sort of the inadvertently left markers of activities that are captured by a particular platform. So not the things that people are actually doing, but just the sort of footsteps that are left in the mud or the snow as they conduct their activities. I think that I would probably, if I were you, reframe the question, and whether online product reviews are digital trace data or not. I don't know if it really matters. I think that you need to describe the type of data that you're using in your paper in a rich manner, so people understand what kind of data that you're using, and then explain and figure out for yourself, what are the things I can say about how people think, behave, and feel with this data, and what are the things that are harder for me to say with regards to this type of data. And that will help you to frame your argument in a way that's consistent with the type of data that you have, and possibly also suggest other types of data that you may want to collect to complement the strengths and weaknesses of the data that you already have. So for sure, you can use online product reviews to conduct both and qualitative analyses, but I think it's not a matter of whether it's digital trace data or not. It's more a matter of what is that data and what are you trying to do with it. So my AirPods failed, but I think I'm using the microphone
on my MacBook now. Oliver and Ann-Cathrine, can you still hear me properly?
We can hear
Yes,
you.
we do.
Yes.
Okay, good. All right. Well, and I think we're soon done here. Yes, this was actually my last slide. I guess we have a few more minutes for additional questions.
Yes, so first of all, thank you so much, Aron, for these insights. I think it was really, really helpful to gain further insights into how to combine qualitative and computational methods, how to really weigh those benefits of both, and how to work with it. So if you have any questions, feel free to put up your digital hands, just like this. So we know that you want to contribute. I'm just stopping